In this problem we're given 5 expressions involving logarithms, and we are to tell which of the following are equivalent to the expression log base b of 2. Looking at the first one, I would start my argument by noticing that I can use a log property that says that any constant factor of a logarithm can be moved up as an exponent on its input. Then I have to recall an exponent rule that you may have learned in a previous course, which basically says if you have some number, in my example 8, raised to a fractional power, some numerator m divided by some denominator n, that you can rewrite that as a radical where m becomes the power on x, and the n here, in my case 3, would become the index of my radical. So in my case x is 8, my m is 1, and my n is 3. So if you don't have a calculator handy, you can evaluate 8 to the 1/3 by rewriting it, at least in your mind, as 8 raised to the first power, and because 3 is in my denominator, it becomes the index on my radical. It being an index of 3 would be read the cube root of 8. The cube root of 8 is 2, because 2 is the number, if you multiply it by itself with 3 factors, you'd get the number 8. All that to say that this expression really is nothing more than log base b of 2. So I know this one is equivalent to log base b of 2. So I'm going to mark that one as being one that's equivalent. The second one here does not necessitate that you know an exponent rule, however, that you know that if you have the difference of two logs, provided they have the same base b, of two quantities, not necessarily the same, x and y, that it can be written as a single logarithm of that same base, provided you take the inputs of the previous logarithms and divide them to form a quotient. So the difference of logs would be the log of the quotient. In my case, my x is 12, so it goes in the numerator, and my y, if you will, is 6, so it goes in the denominator. And since 12 divided by 6 is 2, I again get that this is equivalent to log base b of 2. So we can check this one as being equivalent to log base b of 2 as well. The third one is very similar to the first in that I can think of this as a constant factor of -1, in which case I can move the -1 up as an exponent on the input and rely on an exponent rule that simply says if you have a fraction raised to the -1 power, that it basically reciprocates the fraction. If you'd like me to show steps, x is being raised to the -1. Since the y is in the parentheses, it's also being raised to the -1. This x to the -1 can be written in the denominator as x to the +1. The y to the -1 in the denominator can be brought up in the numerator as y to the +1. And notice, comparing what I started with to what I ended with, basically it reciprocated the fraction. So 1 divided by 2 can be reciprocated as 2 divided by 1. Again, I get log base b of 2. So the third one is also equivalent to log base b of 2. So I will check that one as well. The fourth one, again, is very similar to the first in that I can take this constant factor, or if you want coefficient on the logarithm, move it up as an exponent on the input, and I can again use that exponent rule that says if you have something raised to a fractional power, like 4 to the 1/2, for example, you can rewrite it in what's called radical form, where you copy the base, which is 4, put it under the radical, the numerator of the fraction becomes the power of the 4, and then the denominator becomes the index on the radical here, making this the square root of 4. Since the square root of 4 is simply 2, I once again get that this expression is equivalent to log base b of 2. So I will check off the fourth one as being equivalent to this as well. Lastly, I have the sum of two logarithms, and there's a logarithm rule that says that if you have the sum of two logarithms, provided they have the same base b, you can write it as a single log of the product of the two previous inputs. So the sum of the logs becomes the log of a product. So I can simply take 1/10 and multiply by 20. Don't forget to copy the base b. And since 20 times 1/10 is 2, the last expression here is also equivalent to log base b of 2. So it turns out all 5 of these, although they look completely different, are all equivalent to the same thing.